Formula of complex ionic compounds. The complex ionic compound that contain polyatomic ions. Now we follow what we call the X rule. So for example, whatever charge I have on the first one, I can write it as a subscript next to the other one, next to the other ion. So for example, if I have a 3 here, I'm going to write it over here without the plus. And if I have a 2 here, I'm going to write it next to the first element as a subscript without the plus and the minus. Now, in order to write your final answer, you simply erase the charges like this. So this compound is A2B3. Now let's follow this rule in writing the formula of magnesium nitrate and the other complex ionic compounds given over here. So first, the charge of magnesium is 2 positive, 2 plus because it belongs to group 2. And nitrate ion is NO3 minus 1. Here's the nitrate. Now, you have to know that the polyatomic ions in the ionic compound, you do not change their formula at all. The N, the O, and the 3 has to remain as they are, untouched. So what do? We just remove the 2 plus and the 1 minus and we flip them as subscripts next to the Mg and the NO3. So here, I'm going to remove the 2 and write it next to the NO3. Now, since I have 1 minus, I can ignore the 1 charge. Now, after placing the 2 as a subscript next to the NO3, I can erase it completely from Mg. Now, in order not to read 32, we need to place the polyatomic ion in parentheses. So the final answer is MgNO3. Let's look at another example. Sodium carbonate. Sodium belongs to group 1 and carbonate is a polyatomic ion having a formula of CO3 2 minus. CO3 2 minus. Again, the C and the O and the 3 not to touch, not to change. All you need to do is take this 2 and write it down here. Now, since I have here 1, I can ignore it. And finally, my answer will be Na2CO3. You always have to remember not to leave the charges next to the atom, next to the atoms. Okay, so the next thing now, another example, calcium phosphate. Calcium belongs to group 2, so it has a positive 2, and phosphate has a negative 3 charge. As I mentioned, the PO4 not to touch. All I need to do is take this number over here and write it down, and this number over here, write it next to the first one. In writing your final answer, you should never keep those numbers on top and you should erase the charges with them. So your final answer is Ca3PO4. Now, in order not to read 42, we put the PO4 in parentheses. Another example, aluminum hydroxide. Here's the hydroxide. Aluminum belongs to group 13, so it has a positive 3. And the hydroxide, 1 minus. Again, the number 3, just the number. I take it and I write it down next to the OH, and 1, I can ignore it. Now, when I'm writing my final answer, I need to remember to remove the positive and the negative charges written at the top. And if the polyatomic ion has a number next to it, we place parentheses. Ammonium chlorate. Ammonium is another positive polyatomic ion, and here's the chlorate. So let's write NH4 plus, and chlorate is ClO3 minus. So it's just plus 1 minus 1. In this case, when the charges on the ions are equal and they neutralize each other, there is no need to do the X rule. So for example, in the case of 1 plus and 1 minus, or in the case of 2 plus, 2 minus, or in the case of 3 plus, 3 minus, you don't do anything. You just erase the charges without writing any additional subscripts, and you have the final formula. So now my final formula is NH4ClO3. That's it. Another example, potassium nitrite. Here's the potassium and here's the nitrite. NO2, 1 minus. So NO2, 1 minus. Since I have a positive and one negative, I'm just gonna ignore the charges, erase them, and my final answer is KNO2.